Good evening, everyone. Welcome back to the channel. Tonight we are going to be working on something new, something maybe slightly more complex than I've worked on prior. Tonight we are going to be working on GRE tunnel. GRE tunnel, generic routing. I don't know what the E stands for now that I start talking about this. Meaning of GRE tunnel. Generic routing encapsulation. All right, so let's go ahead and get started. I want to, like we've been doing in previous videos, assemble our topology and then implement everything and see how far we can get. This will probably be a multi-part video because I'm going to do the GRE tunnel first between site A and site B over some internet ISP routers. And then in a subsequent video, we will encrypt that traffic using IPsec, because traffic that goes across a GRE tunnel by default is not encrypted. So it could be, I guess, theoretically intercepted. Why do we use a GRE tunnel? Because if we just used IPsec tunnel, that traffic can only be encrypted if it is unicast, which means no dynamic routing protocols can flow, I guess, back and forth. Anything that's broadcast or multicast won't be successfully encrypted. However, GRE does allow for broadcast traffic to flow back and forth through a tunnel. And so we'll encapsulate the packet in a GRE header, and then we'll encapsulate that in the IPsec header in a subsequent video. So let's work on the topology real quick. First things first, let's do something like this, and we'll actually try to make this nice. I'm going to need a switch and another switch. All right, and then I need a router here and a router here. All right, so these are going to be like, this is going to be like site A and site B, like two office campuses, two office networks that we're going to be simulating. All right, and then they're going to come up here into some internet routers. All right, and so that's pretty good for that. Now I would like to do this. Fill color, select fill color. We'll make this green, okay. And I think the same thing over here. So we'll have site A and site B. And then we'll do something like this for the internet. Kind of this kind of thing. That'll be our internet that we go out to. All right, and then let's do some labels so that it is clear. Site A. And site B. Why? That is odd. Annoying. Note. Side B. Okay, and then I think up here we'll have internet service provider. All right, and then eventually we will have something like this. Okay. We will have a tunnel between these. This will all make more sense once everything's hooked up. So I'm going to get rid of that. GRE tunnel. Okay, so let's do this first. We want to have serial links to these internet routers. So I think I need to zoom in, power this off. 2 serial ports, that's correct. And then power back on. Power off. Drop in, power back on. So that will be, that will allow us to do serial connections. Serial 000 to here. All right. I guess this one also needs that. Back on. Zoom in, power off. Plop that in, back on. All right, now we'll try our serial from 000 to 000. Same thing here. All right, and now these two, they're just going to be crossover. Can go to gigabit to gigabit. Okay. And then for the switch to the router, we'll go gigabit to gigabit 00. The PC, fast Ethernet to, I don't even know, doesn't matter, does it? No. All right, and the same thing on the other side. Switch gigabit 01 to this gigabit 00. Fast Ethernet to this thing. All right, so that's the connections. The tunnel obviously does not have a connection. It'll be like a virtual thing. So no actual connection. All right, so now let's work on our subnets. I'm just going to put a note here. This is going to be 10.0.1.0/24. All right, and then this will be 10.0.2.0/24. So that's going to be side A and side B. All right, and then the connection from the ISP to here to site A, it will need a public 100.0.0.0, and that's going to be a /30 for this one. And we'll make the other one 200.0.0/30. All right, and then in between the two service provider routers, I think we're just going to say 10.0.0.0, and that's also going to be a /30. All right, so now we know that, oh yeah, okay, and now this GRE tunnel, that's going to be, I think, 192.168.1.0/30. All right, so one side, the other side. All right, so I think the way this actually works is, okay, so what's our goal? Our goal, I think, is twofold. First, to establish the tunnel and make sure that packets are being encapsulated with the GRE header, and then also to utilize, GRE to allow for dynamic routing protocol, OSPF, to basically share this site A's subnet with site B's subnet over the tunnel. In reality, this encapsulation occurs, but the packets aren't flowing from router 0 here to router 4 here. They are going across the internet infrastructure. They're just encapsulated such that, they can only be encapsulated, or I guess they're just encapsulated such that these two routers in each of our sites can be established as neighbors. And when we get to the IPsec encryption, this particular router 0, will encrypt, and this will be the one that decrypts. But we're not doing anything encrypted just yet. I think that will be for the next video. But this is our topology. Okay, so let's begin by assigning IP addresses and getting everything hooked up. All right, so first things first, let's do this one. I don't need that. I need to configure this. So fast Ethernet. This will be 10.0.1.100. And this can be /24. All right, and then this will be 10.0 2.100. All right, that's that. Okay, so now I'm going to say, what I would like to do. Packet tracer preferences, just to make it a little easier. I like to show the labels, although they can get a little messy. All right, so G00 will be 10.0.1.1. So CLI, no, conf t, IP interface G00, IP address, what do we say, 10.0.1.1, 255.255.255.0, and no shut. And then its other side, and that'll be 100.0.0.1. All right, so let's say interface serial 000. First, I think we need to do the clock on this side of it. Clock rate. I don't even, 64000 is typical, I want to say. I could be wrong about that. So we set the clock. All right, and now this is going to be IP address 100.0.0.1. I think I'm making things brighter and not brighter. Okay, 255.255.255.252. No shut. All right, so that one is up. Now let's do this one, router 2. So we'll need to make SOOO 100.0.0.2. So CLI, no, conf t, interface serial. What did I just say? O.O.O. IP address 100.0.0.2, 255/30. No shut, and both of those are now changed to up. All right, so that one's done. The same router. Let's do this. What do I want to do? Let's do this router. All right, so did I already do this PC? Yes. So this one's G00 is going to be 10.0.2.1. Let's do that real quick. Interface G00. Is that correct? Yes, 00. IP address 10.0.2.1. All right, and then it's serial exit interface serial O/O/O. Is that correct? O, yes. I want to do clock rate 6400,000. And then what do we got next? 200 dot, let's see, IP address 200.0.0.1 with a /30. No shut. All right. And so that means this thing's OOO is 200.0.0.2. Interface, I can never remember. OOO. IP address 200.0.0.2 /30. No shut. All right, so those are up, those are up. All right, and now in between here, 10.0.0.1, 10.0.0.2 on G00 for router 2. Exit interface G00, IP address 10.0.0.1 /30. No shut. And then on the other side, 10.0.0.2. Interface G00. Yes. G00, IP address 10.0.0.2 /30. No shut. Okay, so IP connectivity, well, not IP connectivity yet. All right, so now, first thing we need to do is some routing. So we need to set default routes from router 0 out of the serial 000 port, and the same thing on router 4 over here. We need to set the default gateways on the PCs. We then need to set up routing between the two ISP routers, which in this case, I think we'll use EIGRP to broadcast, or what do they say, advertise these networks. And then we'll confirm that we can ping from one side to the other once all that's in place. So first things first, over here. All right, so let's do IP route. So this is going to be our default route for this subnet. It's going to go out of serial 000. No. It's going to the next hop address. So that's going to be 100.0.0.1. Which router am I on? Oh, 100.0.0.2. This is 100.0.1. Okay. And the same thing on the other side. And this is going to say IP route O.O.O.O.O 200.0.1. No, .2. Same mistake. All right, so those are default routes. Do show IP route. Okay, so everything out via 200.0.0.2, which is the serial 000 of the next hop router. All right, so that one's done. Now let's do EIGRP on these. So this will be router EIGRP question mark autonomous system number. We'll just give it 1. All right, then we got 2 networks. So we need to advertise the 100.0.0.0 wait, that's question mark, yeah. O.O.3. And then we need to advertise the middle one, 10.0.0.0.3. And then on the other side, router EIGRP process or autonomous system number 1. Okay, and then what is it? First of all, the 10.0 network 10.0.0.0.0.0.3. Okay, we created an adjacency. That's a good sign. And the 200 network 200.0.0.0.0.0.3. All right, so that routing is in place. These 2 route. Okay, and so let's see, can I ping from PC 0? Well, first of all, the default gateway. So the default gateway is a G00 of router 0, which is what? G0 10.0.1.1. All right, so we need to do settings, default gateway, 10.0.1.1. And over here, the G00 of this one is 10.0.2.1. 10.0.2.1. Now from PC0, 10.0.2.0, let's, or no, 2.100. All right, so program ping 10.0.2.100. Can site A ping site B right now? Let's see. Maybe. Doesn't look like it. So what am I missing? All right. Can router 0 ping, let's say, for example, router 3? Let's do 10.0.0.2. Or maybe, yeah. So it can ping 10.0.0.2. And can this one ping 10.0.0.1? It can ping 10.0.0.1. Okay, that's a good sign. Actually, maybe I shouldn't even expect PC0 to ping PC1 yet because there is no routing set up. So maybe that was a little preemptive on my part. All right, so then let's move forward. Let's try to set up this tunnel. All right, so here's the tunnel information. It's going to be between these 2 routers, so we need to work on those routers. So let's do that. Now, Yeah, because there's no static routes or anything like that yet. So we'll say interface tunnel 0. So we create a new interface on router 0 here. And we're going to say question mark IP address 192.168.1.1 255.255.255.252. All right. And now we're going to say the tunnel source is the serial 000 interface. So everything exiting the serial 000 interface goes into the tunnel. And the tunnel destination is going to be the IP address of the serial 000 interface over here on the other side, but it's the public IP address, not the tunneled address. And that's going to be 200.0.0.1. So tunnel destination 200.0.0.1 252. Oh, wait, I don't need to do a mask. All right, so that's a good sign. It's up. All right, so let's go to the other side and basically do the opposite. Interface tunnel 0. IP address 192.168.1.2 255.255.252. Tunnel source is going to be out of its serial 000 port, and it's going to go over to tunnel destination 100.0.0.1. I think that's what this is going to be. 100.0.0.1. All right, so protocol is up. So let me do IP interface brief. Do show IP interface brief. And the tunnel is up. All right, so can we ping each end of the tunnel? Let me see. Maybe not. I don't think so. Do ping 192.168.1.2. Okay, we can. All right, so there it's pingable. And over here, can we ping the other side of the tunnel? Do ping 192.168.1.1. And yes, we can. All right, so we have IP connectivity through the tunnel, which is good. And let's just confirm that we still can't ping the other side, the other, site B private subnet. I don't think we should be able to do that yet because we will first need to set up OSPF between these two. So that's that. I am curious if we do the same thing in simulation right now if we see the encapsulation with the GRE header. So let's do this again. And I'm just curious. Once it gets to this, it's outbound details. Okay, so nothing in GRE, nothing wrapped in GRE yet. All right, so now let's go back to real time. And here we're going to set up IP, I'll do router, OSPF, question mark 1, network. All right, so we need to advertise the 10.0.1.0 network. Network 1.0, 0.0.0.255. And then we also, incomplete command, area 0. We also need to advertise the tunnel subnet. Network 192.168.1.0, 0.0.0.3, area 0. All right, I think that's that part, yes. And then the same thing over here. We need to advertise the 10.0.2. So we'll say router, OSPF, question mark 1, network 10.0.2.0, 0.0.0.3, area 0, and network 192.168.0, 0.0.0.3, area 0. Exit. All right, so that is another good sign. We've got a neighbor relationship formed. So let's say do show IP route. And there are now routes through the tunnel to the 10.0.1 subnet over here. So let me just go ahead and try to ping from this side over here. No, actually, I'll just try to ping from PC0. So PC0, I'll try to ping PC1 again. Okay, so ping 10.0.2.100. Let's see what it does. Okay, we got some replies. All right, so that is good. So that means, what I think it means is that traffic will come up here, it'll traverse across, but while it's in this section, going across all the routers in the internet or whatever, it will be encapsulated in a GRE header. And through that tunnel, those dynamic routing updates can flow, which is pretty cool. And that's why OSPF works, and that's why these two routes got to be shared successfully. And now PC0 can ping PC1. But let's do another simulation, and we can take a look at the actual packet and confirm that it is wrapped correctly. All right, so that's that. So let's get up to this router and then look at the outbound PDU details. And as you can see already, okay, here's the header. And so it has, IP header with a source and destination from 100.0.1 to 200 in GRE, and then again, the private addresses 10.0.1.100 to 10.0.2.100. So there's like two IP headers on this. The second one, I believe, is embedded inside the GRE header. All right, so let's get rid of that and just kind of follow it along. So it's going to go up and over. And I think now, once it gets to this side, the outbound coming out of it will no longer have. So it's been de-encapsulated. All right, so let me once again get rid of some of this extra clutter. What we have currently is a GRE tunnel set up between two different sites, or 2 different offices, you could say, in different sides or different areas of the internet through a simulated internet service provider, and they are able to successfully communicate, and the packets that they are communicating via are successfully encapsulated and allowing for dynamic routing protocol, OSPF, to create neighbor relationships through that tunnel. All right, so that'll be the end of this video. Next, we're gonna start with this setup, and we will encrypt the traffic so that anybody out here that intercepts this traffic cannot read it, cannot man in the middle it. And we'll set it up such that router 0 will encrypt it. Anything that goes out through the GRE, out across the internet, comes back and gets decrypted on router 4, or whatever this is over here. I guess this is actually router 1. And at the same time, because IPsec is only unicast, multicast traffic can flow through and encrypted, and allowing us to share routes dynamically, which is the whole name of this game, I think. So as you can see, kind of getting slightly more complex compared to what we were doing only a couple months ago, which is exciting. And I hope to just keep going and learning more and more. It's been very interesting, very fun. This one in particular feels like could be real life. Like this is how you might actually set something up in a real life environment. So thanks for watching, everyone. Hope everyone is enjoying the channel and enjoying these videos. Let me know if you have any questions in the comments, and I'll talk to you all soon. Thanks. Bye.